All right, properties of exponents using mathematical operations. So we are on 4-3. We're going to now take our exponents that we've understood, learned all their characteristics, and we're going to do basic operations: multiplication, division, and power to a power. Multiplication. If the base is the same, you just add the exponents and keep the base. So 3 to the 6 times 3 to the 2nd. I add 6 plus 2. My answer is 3 to the 8th. How about if we make sure that we can see that? What is the proof of that? Well, 3 to the 6th, here it is, my base of 3 repeated 6 times 3 to the 2nd, so 3 repeated twice. Remove all those parentheses because you don't need them for multiplication or addition. And you have the base of 3 repeated 8 times. There's my proof. This works even if the exponents are negative. 3 to the negative 6 times 3 to the positive 2, negative 6 plus 2, 3 to the negative 4th power, which becomes 1 over 3 to the positive 4th power. Remember those rules of negative exponents. Division. If I do division, if the base is the same, you can just subtract the exponents and keep the base. So I have a base of 3 to the 6th divided by 3 to the 2nd. 6 minus 2, 3 to the 4th. Again, I want to show you the proof so you understand why that works. I have all of my 3's. I can cancel out all of my duplicates, and I am left with 3 to the 4th power. Another example. 3 to the 7th power divided by 3 to the 2nd power equals 3 to the 7 minus 2, which equals 3 to the 5th power. All I did was subtract my exponents. 3 to the 3rd over 3 to the 5th. What if it's in fraction form? It's okay, but you always do numerator minus denominator, regardless if you end up with a negative exponent. So here I have 3 as my base to the 3 minus 5 power, 3 to the negative 2, which of course moves to the denominator with a positive 2. My answer is 1/9. What if I have power to a power? In this case, I have, well, and I'm going to multiply my exponents, which seems like, well, shouldn't I have been doing that already? But no, because multiplication told you to add them. Only in power to a power do you multiply the exponents. So I have 3 to the 2nd raised to the 4th. I feel like I'm playing a card game. 3 to the 2 times 4, 3 to the 8th power. How am I going to prove this to you? Well, 3 squared is 3 times 3, which is 9. Raised to the 4th power, 65, 61. 3 to the 2 times 4, 8th power, 3 to the 8th power, 65, 61. My solution is in exponential and standard form. This is exponential, this is standard. 4 to the negative 2 to the 3rd power. Well, negative 2 times a positive 3 is a negative 6. Move it to the denominator, 1 over 4 to the positive 6, 1 over 4,096. Your calculators will do this for you, but you know, when you're taking a test and you don't have a calculator, or you need to be able to just look at something and say, that doesn't seem right, because you know what the rule is. Let's practice. 5 to the 6th times 5 to the 9th. 6 plus 9, 5 to the 15th. 16 minus 4. 5 to the 16 minus 4, 5 to the 12th. I have 9, here we go. This is going to be interesting. 9 minus a negative 4. I'm not allowed to have double signs. Clean it up. 9 plus 4. I have t to the 13th power. This is extremely important. 7 to the 4th raised to the 3rd, 4 times 3, 7 to the 12th. Your big deal here was number 3, realizing you can't have double signs. Simplify. Well, here I had 4 to the 3rd times 4 to the 2nd times 3 to the 2nd. When I see the same base, I can combine, but only if it is the same base. So 4 to the 3rd times 4 to the 2nd, 4 to the 3 plus 2 became 4 to the 5th times 3 to the 2nd. Nothing to combine the 3 to the 2nd with. Note, 4 to the 2nd is not 4 times 2. This is the biggest mistake you will make. Even when you get good at this, you go too fast and you're going to write 4 times 2. Please take your time. 4 to the 2nd is 4 times 4, and there is a big difference between 8 and 16, especially if it was money. 4 to the negative 2 raised to the 6th, negative 12, move it to the denominator. Let's have a little enrichment practice. Let's do something a little more fun here. 3 to the negative 2. As soon as I see a negative exponent, remember, put in your fraction bar. 3 to the negative 2 moves to the denominator. 4 to the 5th stays in the numerator. 6 to the negative 8 has to move it to the numerator. Negative exponents become positive exponents and move to the inverse location. Positive exponents stay where they are. Let's try a few. Pause the video. Let's do a few examples. Answer in standard form. Standard form means the actual answer. So what is 10 to the 9th? There we have 9 zeros. We have our thousands, our millions, and 1 billion. Negative 3 moved to the bottom. 11 to the 3rd power, the bottom, the denominator. 11 to the 3rd power, 1,331. 2 to the 7th, 1 over 3 to the positive 4, 1 over 81. Try these. You may be using a calculator by now. You may have found the correct buttons on the calculator that allow you. It's usually a y to the x, usually at a second level on a basic scientific calculator. If you use the second key and you're looking for y to the x, you should be able to do these. But let me just give you these final answers. 3 to the 3 minus 6 power, 3 to the negative 3, which is 1 over 3 to the positive 3. Again, I can't do fractions with this software. 7 to the 9th, well, I can do them, but it just is very difficult. Sorry. 7 to the 9th times 7 to the 2nd, we add them. 7 to the 11th. Here's where you multiply. 5 to the 10 times 6, 5 to the 60. Here I have negative 7 minus 7. Okay? So at first you might have said, well, I've got a negative 7 and a positive 7. Combine them, it's a 0. No, you have to subtract. It's a negative 14. This is 1 over 11 to the positive 14 because I have to move this 11 to the negative 14 down to the denominator. I suggest you watch the video over again. Just make sure you understand these negative exponents and the rules of the operations. Good luck with exponents.